Mesh analysis of a AC circuit. Definition: mesh analysis is a method of circuit analysis where we assume loops and apply Kvl rule to the loops to find out currents of the different parts of a circuit. So the main points are loops, Kvl rule, and to find out the currents. Finding out the currents is the main job of mesh analysis. So we'll discuss about mesh analysis of a circuit with a independent voltage source. For analyzing we have some steps, so let's see what are the steps are. 1. Assign a current in clockwise direction, and you can choose anti-clockwise too. To indicate polarities of impedances. Since it's a AC circuit, we have impedances here, not resistance. But polarities of sources are untouched, so you cannot change the polarities of the sources. 3. Apply Kvl rule to the loops. 4 is to solve the Kvl equations and finding out the currents. So let's draw a circuit. This is the independent voltage source, and this is a inductor. This is the resistor, and this is the capacitor, and again a independent voltage source with the sine wave in the middle. And this is the ground. So let's put the values. U1 equal to 2 volt angle 0 degree, the independent voltage source, and inductor XL equal to 2 ohm, resistor equal to 4 ohm, and capacitor XC equal to 1 ohm, and the second independent voltage source E2 equal to 6 volt angle 0 degree. The polarities of sources are given on the equation, and you cannot change it when you analyze it. And we can simplify this circuit. Actually this is a simple circuit and you don't need a simplification, but when you have inductor, resistor, and capacitor all in a series, then you need a simplification of a circuit. This circuit does not need the simplification, but I'm just showing you the way. Here you can assume XL equal to Z1, R equal to Z2, and XC equal to Z3, and they are all are impedances. And remember, these are independent voltage source. We are analyzing a independent voltage source circuit. And the polarities should be same of source. Now assigning the currents in clockwise, which is the loops, and assigning the polarities of impedances, we have to remember that entering side is positive and leaving side is negative of impedance, entering side of current. So this is the simplification of this circuit, which is not really need, but you can do it. So the Kvl rule, we have to apply Kvl rule to the loops. For loop 1, U1 minus I1 Z1 minus Z2 into I1 minus I2 equal to 0. This is for loop 1, and we can simplify this equation too. So this is the simplification of loop 1. So you can give the equation 1, and for loop 2, minus E2 minus Z2 into I2 minus I1 minus I2 Z3 equal to 0. This is for loop 2, and we can simplify it too. Okay, so this is the simplification of loop 2. So now we have to solve the equations to find out the values of I1 and I2, and we can use Kramer's rule to solve this. We cannot use calculator to solve this because calculators cannot solve complex equations, so we will use the Kramer's rule. So I have derived a easy formula for this. This is a derivation of Kramer's rule. So I am putting the I1 coefficient of I1 on the left side of a matrix and coefficient of I2 on the right side of the matrix. And multiplying another matrix which contain I1 and I2 equal to matrix of E1 and E2. So we can write it like this way, like I1 equal to the whole determinant of impedance on the bottom I am writing this whole thing in the bottom, and for I1 we are putting on the left side E1 values, E1 values on the left side, and the right side is as before, Z2 plus Z3. This is the easy way to solve the complex equation. See that I wrote E1 and E2 on the left side because I1 was on the left side and I2 was in the right side. If you wanted to find out I2, you have to write E1 E2 on the right side. Now let's solve the determinant. Z1 plus Z2 into Z2 plus Z3 minus Z2 whole square. This is the rule of determinant. So let's put the values. So Z1 equal to 2 ohm, sorry, Z1 equal to 2 ohm, Z2 equal to 4 ohm, Z3 equal to minus 1 ohm. Oops, I did a mistake. Z1 equal to plus J2 ohm. I have to write J here because this is a inductor, and Z3 equal to minus J1 ohm for capacitor. Remember, this J here is I on the calculator, which is the complex number or complex function I equal to root over minus 1. So I1 equal to 3.61 ampere, angle minus 236.30 degree, or 3.61 ampere, angle 123.70 degree. For I2 you can put the values of I1 in equation 1 or equation 2. It's your choice. So let's put the I1 in equation 1. What is the equation 1? It is this one. Okay, I1 into Z1 plus Z2 minus I2 Z2 equal to U1. I'm just simplifying the equation. So after calculation, so value of I2 is 4.47, angle 153.44 degree ampere. When we apply mesh analysis, we generally see four cases in terms of sources. One, circuit with independent voltage source. 2, circuit with dependent voltage source. 3, circuit with independent current source, and 4, circuit with dependent current source. In this video we discussed the first one. We will discuss about the next three in next video. Thank you for watching.